Hey, welcome to YouTube, ladies and gentlemen. This is our bonus scope. Now, let's do this. A particle with mass m is confined to an infinitely deep, hey? One-dimensional square potential well of width a. Okay, what does that mean? Now, if you've seen our lectures on gabversity, this is a summary. So I would advise go back and look at the quantum mechanics lectures on gabversity. Now, can I share this with anyone? Share. How do I share? So forgive me, I'm sharing right in the middle of my scope. So you're gonna have to wait and bear with me while I hit share. Oh, I think I did already. Did that work? Looks like it's done already. I don't even know. All right, so let's begin. Oh, we're back. All right, I don't know. I don't get it. I don't know if I was there or not. Let's just get cracking. So, as we said, this is all mathematics, right? Let's do it. Let us begin. So now what we have V of x, which is the potential. It equals 0, right? It equals 0 when for 0 is less than equal to x, less than equal to a. And then it's infinity otherwise. That's a bit blurry. Okay, what does that mean? Well, it means that the equation of energy only exists at this point where V of x equals 0. Okay, so between 0, so x is between 0 and a. Now, let's give this a go. What we can see is that the second derivative of the wave function, as we use the original equation, it works like this. It is minus h bar squared over 2m multiplied by the second derivative of the wave function with respect to x equals energy by the wave function. Well, what does that mean? Well, that means that the second derivative multiplied by the wave function, the second derivative of the wave function with respect to x equals 2m minus over h bar squared energy by the wave function. Now, what we can do is we can let this section here, just the positive section, equal k squared. Okay? And by doing that, we let that equal k squared. I'm not going to write it, but just let that equal k squared. And that implies that the second derivative over the wave function equals negative k squared by the wave function. Now, this is quite interesting because now there is only one sort of equation which for this to be true. And you can write it in the form of exponentials or in the form of sine and cos. So what we'll do, this implies that the function has to equal a sine kx plus b cos kx. That is the only equation where if you derive it twice, you will get minus some constant squared of this x multiplied by the original function. And if you've done any sort of university or college calculus mathematics, you will prove this. Okay, so the other thing we know is that at the boundaries of the well, we've got 0, okay, that equals 0, and the boundaries are at 0 and at a. So that implies that the function at 0 equals 0, which equals a sine k by 0, which is 0, plus b by cos k 0, which is 1 times b, because cos of 0 is 1. Okay, so that means b. And the only way 0 plus b can equal 0 is if b equals 0. So therefore, this equation has to equal a sine kx. Now, the other thing we have to figure out is what the hell is k? Well, we know that the function at the other end of the well is a. And it equals 0, which equals a sine ka, because a is now taking the place of x. Well, the only way, apart from a being 0, the only way that sine ka can equal 0 is if Ka equals n pi, where n equals 0, 1, 2, all the way up, right? In other words, sine of 0 and then sine of pi, sine of 2 pi, 3 pi, 4 pi, 5 pi, just goes around and around and around. Okay. So if Ka equals n on pi, that implies that K equals n pi over A. But now we come back all the way to the start. Remember what we did at the start? We said that this thing here is K squared. So that implies that 2 by the mass by the energy over h bar squared equals, it's going to equal this squared, which is n squared pi squared over a squared. So therefore the energy can only exist at, let's put the h up there and the 2m down here, h squared n squared pi squared over 2m a squared. That is the only way that you can have that particle existing. You have to have the energies as multiples of this. So 1, that'll just become h squared pi squared over 2m a squared. If you have a 2 in there, it'll be 2 2s are 4, h squared 4 pi squared 2m a squared. So therefore, the first energy level is going to equal h squared pi squared over 2m a squared. And the second energy level, 2 squared is 4. So that's going to be h squared by 4 and the 2, so that 2 will cancel, and what we left up here is 2. So 2h squared pi squared over m a squared. Solved. So there you go. We have figured out what the energy level has to be. It is h bar squared for the first energy level. So the pixel size of the universe slither squared by pi squared over 2 times the mass by a squared, which is the location, the distance of the world. Okay, that is the first part of what we wanted to solve. Where am I? Yes, I have solved it. Excellent. So the next one is now we want to normalize this so we can figure out what the hell the function actually is. Now, if you remember, what we did was, we know that the function so far equals a sine kx. Okay, so we want to figure out what a is. So what we do is we normalize. So we know that normalizing equals 1. So 1 equals the integral a squared sine squared kx dx, which equals a squared, and it's minus infinity to infinity. Okay, and that, it's actually from 0 to a. Well, it doesn't matter, because 0 and a are within there, because the rest is all nothing. It equals nothing. Particle doesn't exist outside of the world, so it doesn't really matter. Okay, so a and the integral of sine squared kx equals, and this is in your tables, right? Because it's physics, you don't have to actually prove this, minus sine 2kx over 4k, okay, from 0 to a. Now, when we put 0 in there, 0 is going to be 0, and 2 sine of 0 is 0. So you don't have to worry about that. We just put the a in. And that equals a squared, a over 2, minus sine 2ka over 4a. So sine 2ka over 4a. Okay, now what's interesting about this what have I done now? 2ka over 4k. The k, if you remember, k is equal to the square root of this, and that means that the a and the a cancel out. Okay, and if they cancel out, this is going to be 0, and I'll show you what I mean. It equals a squared outside of a over 2 minus, and we know what the k is, right? It's sine of 2 multiplied by h squared n squared pi squared, then we times it by a because it's 2ka over 2m a, and the m is square rooted, right? So where am I here? Let me just make sure I've done that right. Yes. Now the a's cancel, which means that you have a whole number here, and the sign of anything whole number pi is going to give you 0. Now we said k a and k equals n pi on a. That's what it was. K equals n pi on a. Yeah, so they cancel out. All right, so that's it. So we're left with only a on 2, which implies that a squared equals 2 over a just by moving it to the other side, and square root equals a. So a equals root 2 over a. Done. And if you haven't seen the other lectures, none of this will make sense. The other ones I go through each step really, really slowly, and I go for like an hour explaining each step and why it's done. So I recommend go look at those at Gabversity on Periscope. Okay, let's look at the next section. Next section is we want the value of x, expectation of x. So the expectation of x is going to equal, as we know, the integral of x by the normalized wave function squared dx, which is going to equal 2 over a by the integral from 0 to a of x sine squared n pi x over a dx. Okay, and what do we got here? I made a little mistake in the last one, but the answer was the same, the one I just did. That's all good. I said k equals 2mh or whatever, but it's just n pi over a. All right, so 2 over a, blah, blah, blah. So what is that? Well, that is going to be 2 over a outside of this. Remember that it is when you are integrating something that is a product of two functions, which is one is x and then the other one is sine squared n pi x over a, you have to do the integral, which is uv, which is this multiplied by the integral of this, minus the integral of this by the derivative of this. And it's very simple because the integral of this is what we just did, the derivative of this is 1. So let's do it. uv, which is x outside of, and we just did this, x over 2 minus sine of 2n pi x, sorry, 2n pi x, 2n pi x, yeah, that's right, over 4a, and that's that section, and that's from 0 to a, and we close that off, minus the integral, and we say v du, which is just the integral of x over 2 minus sine of 2n pi x over 4a dx. I can't fit the dx in there, but that's from 0 to a. And then we close all this off. Okay, so what's that? Well, that's 2 over a, and then we put a in here, and we know that that's going to make that 0, and it's going to be 0 either way. Because when you put a in here, a 2n pi a over 4a, hold on a sec, what have I done? Because that's 2n pi over a, that's where I stuffed up. So then a and a cancel out, so that'll be just 2n pi, which makes it 0. Okay, so x over 2, that means it's going to be x squared over 2, so that's a squared over 2, so that solves this section. Now this section here, we want minus, the integral of that. So the integral of this, that's going to be x squared over 4, and the integral of this, and that's 2n pi x over a, I forgot that, I keep forgetting that. Okay, so that's going to be, that'll be plus a over 2n pi times 4a, because of down here, and then cos 2n pi over ax from 0 to a. Okay, and that is going to be 2 over a outside of a squared over 2, just like before, minus, now let's put everything in here. The a, if I put an a in all of this, I'm going to get x squared over 4, which is a squared over 4, plus, and then I'm going to put an a in here, which just makes it cos of 2n pi, which is always going to be 1. So I'm going to be left with a over 2n pi times 4a, and all of that is minus, and we substitute in 0 in here. So 0 over 4 is 0, and 0 in here makes that 1, so it's minus this again, a over 2n pi times 4a. And these cancel out, so we're left with 2 over a outside of, what's a squared over 2 minus a squared over 4? It's a squared over 4. And that, the 2 and the 4 will cancel, so you're going to be left with 2, a cancel, a over 2. Now, are we correct? Yes, we are. So the expectation value of x is a over 2, and it doesn't matter which energy level, it's always at the same, a over 2. Okay, now for momentum, momentum's easy. This is the last thing. Momentum, or the expectation momentum, equals the derivative of the expectation of x multiplied by mass with respect to time. Now, we want the derivative of a over 2. Well, the derivative of a constant is 0, so it's going to equal 0 by m, which equals 0. And we're done. We solved that problem in 17 minutes. I'm happy with that. All right, it was good to see everybody, and interesting to do it on YouTube with no viewers at all, but there you go. Good to see you. Facts don't care about your feelings. Hey, gin and tonics just appeared.